Absolute, fractional, and percentage uncertainty, again, are really important for paper 3. So in order to do this, we have to understand sort of a measurement. So in this case right here, we're going to be using this example of measuring just something. That thing you measure, that could be a distance, it could be a force, it could be whatever. In this case here, I'm just going to call it a thing A. Now that thing A has some sort of associated uncertainty with it when you actually measure, right? You're going to have A, but you're not going to be exactly sure what its value is, right? You could be a little bit uncertain. So that's why I'm going to put an A plus or minus, you know, some sort of, I don't know whatever this uncertainty is. It could be like 0.1 or whatever. So this is what I mean here. So you're going to have some value plus or minus whatever that uncertainty was. So the definition then of absolute uncertainty, it's super easy. The absolute uncertainty is just plus or minus delta A. In other words, the absolute uncertainty, it's the actual value of your uncertainty. So if you're measuring a distance of like 2.0 meters, then the uncertainty would be like 0.1 meters. So it's an actual literal value. Whereas the fractional uncertainty, hopefully that'll tell you a lot more about it, right? Fractional implies a fraction, duh. So in order to do that, you can actually figure it out. The fractional uncertainty will simply be the uncertainty on your measurement A, and you're going to divide it by A itself. So that's how you're going to find the fractional uncertainty. Now the percentage uncertainty is just like the fractional uncertainty, except you multiply by 100. That's it. So in this case here we have delta A over A, and we have that times 100. And that's how we find the percentage uncertainty. Now you might be wondering, okay, well, when do I need these? Actually, I mean, very often, if you're actually going to be measuring something, you're going to need to know the absolute uncertainty. But a good trick is to actually use the percentage uncertainty. And this is something I'm gonna try to show you here. So I have a nice trick for you here. First of all, I mean, these kind of questions, a lot of people don't know what they're doing. That's why I like this. I have no idea what they're doing. And you know, that mean probably, right? So a nice trick is that if you have things multiplied or divided, and when I say things, that could be really a lot of different things. Okay, oops, I realize it's sort of off the screen. So let me just fix it here. So if you have things that are multiplied or divided, let's see here if I can fix it. There, nice. Then what you end up doing is you can add up all the uncertainties on whatever value you are measuring. So in this case, if you're measuring a distance and a time, let's just say, and you want to find the velocity, even though the velocity is the distance divided by time, or displacement divided by time, if we're going to be really accurate about it, then what you can do, you can just find the percent uncertainties for each of them. You can find the percent uncertainty for distance, the percent uncertainty for time, and even though the way you calculate velocity is by doing the distance divided by time, it sounds complicated, but if you have things multiplied or divided, which in this example I'm telling you, you do, then all you have to do is just add up the percent uncertainties and you'll get the uncertainty on the total value. And I think to make it make more sense, I'm going to use that actual example there. So here we go. We have an actual example here. So what's the percent and absolute uncertainty on the speed? So here we have a distance of 10 meters plus or minus 1 meter. And we have a time of 5.0 seconds plus or minus 0.2 seconds. So to find the percent uncertainty, that might be a good one to start with, right? So let's do the percent uncertainty. The way we're going to find that, we're going to remember that equation, right? That we first have to do the fractional uncertainties on each. So let's do the fractional uncertainty on distance. So for distance, we have the fractional uncertainty is going to be delta D over D, which in this case, the uncertainty on D is just 1, and the actual value of distance is 10. So in this case right here, remember, well, I'm right now I'm actually finding the fractional uncertainty, which gives me 0.1. Now to do the percent uncertainty, remember I have to take that and multiply it by 100. So what I do, I move my decimal over by 2, and I end up with a percent uncertainty of 10% on the distance only. We can do the same thing for time. For the time, we have delta t over t. I'm doing the fractional uncertainty on the time, and it's 0.2 divided by 5. And I do that, what do I get? I get 0.04, don't I? I think so. Yeah. 0.04 times 100, of course, to get the percent, and end up with 4%. All right. Now, how does this help me? Well, I want to find the velocity. The speed. And the speed itself, remember, is given by this equation, v equals d over t. The speed is the distance over the time. But remember that little trick I showed you, that to find the uncertainty on the total value, all you have to do is just use both of these right here, and you can just add them together. So 10% plus 4% is 14%. So you have a 14% uncertainty on your speed. Your speed has a plus or minus 14%. So we're done that first one. What's the percent uncertainty? Done. We got it. Now to do the absolute uncertainty, you could work it all out with that equation. Do delta d over d plus delta t over t and multiply that by v. You could absolutely do it that way. See, absolute, huh? But instead, let's just use this percent uncertainty. If we know that the, we know the percent uncertainty, so that's actually really good. We know that the value, let's see, the speed is going to be just 10 divided by 5, right? We know that it's going to be 10 divided by 5, which is just equal to 2. We don't know how many decimals to put, right? But we know it's 2 meters per second. So here's the thing. To find the absolute uncertainty, we can just use the percent uncertainty. We know that our value is going to be 2 plus or minus 14% of 2. So all you have to do then is multiply with your trusty calculator. I'm going to do 2 times 0.14, and I get an answer of, I don't know if you can see it, but it's 0.28. So I end up with the uncertainty, so delta V in this case right here is going to be 0.28 meters per second. But do you remember what you have to do? Your uncertainty has to have one non-zero number. So in this case, I'm going to change it then to make it delta V is 0.3 meters per second. This is my uncertainty on the speed, the absolute uncertainty. If I really wanted to write everything correctly, I would have written it like this, right? That the speed is actually 2.0, because now I know I'm only allowed 1 after the decimal, plus or minus 0.3 meters per second. So this is sort of how I would write the speed. I hope that makes some sense, at least. So for calculating these right here, really important for paper 3, really, really important.